All right, everybody, welcome back to part 2 of RE4, zero and negative exponents. So in this part, if you haven't already watched part 1, please go back and watch that first. In this part, we're just going to tackle a few more problems to give you a little bit more practice and hopefully some more confidence. So looking at the first problem that we have not worked yet, in this one, really, the only thing we're seeing that's not okay is just this negative exponent up here. We know it's not okay to have negative exponents. Anytime you have a negative exponent, you can either move it from the numerator to the denominator or from the denominator to the numerator to make it positive, right? So since this one is on top already, if we move it to the bottom, we know that that exponent's going to become positive. Now, on the bottom, we got to kind of be respectful of what's already down there. There was already that 4 that was down there on the bottom, so we want to make sure that that 4 stays there. We don't have to move it to the top. This isn't flipping the fraction. It's just putting stuff where it works. Now, there also was a y to the 5th here, but I'm going to leave a little bit of space there. And the reason is I'm going to put this x to the positive 6, the one that we moved down, in that spot. And the reason I put it in that spot is we normally like to make our variables go in alphabetical order. So x comes before y, so we should see x before y. Now, if you notice, there was nothing that we had to move to the top, right? Nothing got moved up. So since there's nothing there, we got to make sure we hold the fraction. So we put a 1 up on top to hold that fraction. And this would be our final answer. Moving on to the next problem. Down here we see some parentheses. And like I've told you many times, when I see parentheses, I like to think about PMME. Parentheses mean multiply exponents. In order to do PMME, we got to make sure everything inside those parentheses has an exponent on it. That's the piece that you're going to have to remember. So if I distribute this -3 to each of those exponents, remember our bases are not going to change. So I'm still going to have the same base of 4, the same base of x, and the same base of y. The only thing that's going to change here are the exponent powers. So when I take -3 times 1, I know that's going to give me a -3. When I take -3 times a -4, that's going to give me a positive 12 on the x. And when I take -3 times 2, that's going to give me a -6. Now, we've done really good work up until this point, but we're not allowed to finish our problem with negative exponents. So, as I've told you, and I'll continue to tell you, anytime you have negative exponents, if you turn it into a fraction to start, it gets a little bit easier to deal with. So, we want to take anything with a negative exponent and move it to the bottom of our fraction. So, that's going to move down. And this is also going to move down. So that x to the 12 there has no reason to move though because it has that positive exponent. So up top I'm going to get x to the 12th. And then across the bottom I'm now going to have 4 to the positive 3rd power and y to the 6th power. We can go just a hair further with that if we wanted to. Sometimes you'll see this done. Other times it'll be just left with 4 to the 3rd. But 4 to the 3rd is really just 4 times 4 times 4. We can check that out on our calculator if we're not sure. I think it's 64. 4 to the 3rd power, 64. So I can rewrite 4 to the 3rd as 64, right? That's the part that changed, but I still have y to the 6th down there on the bottom. Nice job. Moving on, let's look at another one. This looks like a toughie. Now, a couple of things I'm noticing right off the bat. I'm trying to make my life as easy as possible before I dig in too deep. The first thing I notice is I have a couple of variables that are raised to the 0 power. So we can actually cross those out. Since we know those just become big giant 1s, we don't have to worry much about them. Now, we should still go a little bit further here because looking at this problem, I do see that I still have negative exponents all over the place. So what we want to do is we want to move this to the bottom. We're going to want to move this to the bottom. And then this guy, we're going to want to move to the top because he also had a negative exponent. Now, notice over here, this 3x to the 3rd, that does not need to be moved because it's positive exponents on there. We don't have to worry about that. So when I rewrite this with those changes, I'm still going to have 3x to the 3rd, but now since I brought this x to the -4th to the top, I'm going to have an extra x to the 4th up top. Looks like we have a little bit more simplifying we can do there, but let's save that for a minute later. On the bottom, now I'm going to have y to the first power. Remember, that becomes positive when it drops down. And z to the first power. It's good practice to write those first powers in there, but you don't have to. It doesn't make it right or wrong one way or another. You want to be okay with the idea of saying these ones can be there or they can disappear, and either one is okay. Now, the last thing I see is that I have x's over here and x's over here. So I want to make sure I put those on the same pile. Those are really just being multiplied together, so we just need to come over here and add those exponents to get to our final answer. 3 plus 4 is 7, so I'm going to have 3x to the 7th power over yz. And again, if you wanted to leave the first power on the y and the z, that is absolutely okay, but you don't need to. Moving on to the problem below it. These are my favorite kinds of problems. Hopefully you notice this zero exponent here, right? And remember, anytime you have anything raised to the 0 power, it's always equal to 1. Don't fall into the trap, ladies and gentlemen. Intuitively, we like to think that anytime we have something raised to the 0 power, that it's always going to be equal to 0, but that's not true. And that's really, I think, goes back to our super huge idea number 3. Any number raised to the 0 power is really equal to 1, right? So don't fall for that trap and make it a 0. You got to make it into a 1. Wonderful. Here's another problem for us. You can tackle this problem a couple of different ways. The way I think I'm going to show you is let's just be consistent with that PMME idea, and I'll show you a second way after that. So if I was doing this by PMME, I would have to put in my 1s before I can multiply exponents. And I know I'm going to multiply to there and to there. So I'm going to end up with 2 over 5. My bases don't ever change here, but my exponents do. 1 times negative 2 would be a negative 2. 1 times negative 2 would be a negative 2. Now to move on from that, remember, anytime you have a negative exponent, you need to move it to the other side of the fraction. So this is going to move down, and this time, this actually needs to move up as well because it also had a negative. So I'm going to get 5 to the 2nd power and 2 to the 2nd power. 5 to the 2nd power is really equal to 25, and 2 to the 2nd power is really equal to 4. Depending on how you're submitting your answer, actually, you could look at either one of those being correct. Most of the time, I would say that we're actually going to simplify like we did over here, but sometimes we might just leave it with the base and the exponent like we see. So this was the first way you could think about this problem. The second way you could have thought about this problem was something similar to what we did in part 1. And we said anytime we have a fraction that's being raised to that negative exponent, what we can do is we can actually just flip the fraction right away, and that actually makes that negative sign go away. Now, looking at that, we still need to do some PMME, right? We got to distribute that 2 kind of all the way through to those exponents. The base isn't going to change, and the exponent is the only thing that's going to change. So I'm going to have 5 to the 2nd and 2 to the 2nd, which hopefully you're seeing that right over here as well, and you're saying, oh, I see, those are the same thing. So 2 different ways to do the same problem. Do whichever one works for you. This is the last problem we're going to tackle in this part 2 video. And let's do it 2 ways again, because again, we have a fraction on the inside that's being raised to the negative. So I think the way you're more familiar with right now is the PMME. Parentheses mean multiply exponents. So first we need to make sure each of these has an exponent in there. And then we are going to multiply the negative 2 to each of those exponents. Now, our bases are not going to change. They're going to stay exactly the same. What's going to change are our exponents. And when we have parentheses, we multiply. So negative 2 times 1 is going to give me a negative 2. Negative 2 times 1 is going to give me a negative 2. We're going to get a negative 2 and a negative 2 when we make those last 2 multiplications as well. Now, remember, anytime you see something that has that negative exponent, you need to move it to the bottom or to the top respectively. So this will move down, this will move down, this will move up, this will move up. What will we be left with? Well, we'll now have 9 squared up top and c to the second. Right? Our bottom goes up top, but now our exponents are positive. And on the bottom, we're going to have 2 to the second and a to the second. Our exponents are now positive again. The last thing we should do is simplify. 9 to the second would be 81 c to the second. And then we will have 2 to the second, which is 4 a to the second. And this would be our final answer. Again, just like we were saying before, sometimes that might be okay too. Thinking about your tests and your quizzes, we might try to test you by just leaving it in that form as well. The last way you could have considered this problem, and I'm okay if you only know one, but you really should have some idea, be able to watch and understand what's going on here, is that if I had 2a and 9c, and they were both being raised to the negative 2 power because it's all in parentheses, when I have a fraction inside here, that's bad color choice, when I have a fraction inside and it's being raised to that power, and that power ends up being negative, what we can do is we can just simply flip that fraction to begin with and leave that power positive on the outside, or change that power. That negative really just has to do with that fraction flip that needs to happen. And from here, we can just finish our problem by going through and multiplying exponents. These all, of course, have a 1 on them, so I would get 9 to the second, c to the second, over 2 to the second, a to the second. Wrapping that up, we can always simplify 9 to the second to be 81, because that's what 9 times 9 is. And 2 to the second is just 4. And we are done. And notice how we got the same answers both times. We just went through and went all the way. Again, ladies and gentlemen, if you have any questions, please be sure to reach out to your teacher. We are here to help. Thank you for taking the time to watch this video. Have a great day.